Hello, my name is Daniel Oliveira. I'm from the University of Minho, Portugal, and I'm very happy to participate in the Symbol Final Conference. So the work I'm bringing here is about the development of a digital-based approach for the preventive conservation of cultural heritage buildings. This work was developed inside a project that is Heritage Care Project, and I will show you the most important results obtained in the project. Well, as a common practice, we go to the garage with our cars, even if the cars have no problem or no apparent problem, because we understand this is important to preserve the cars so in good shape, to avoid the future problems. We do the same for our health. So we go to the doctor, we perform some blood tests and other things to check our safety, our health. And we do this again, even if we don't have any apparent problem. So we do this because we understand this is important for the future. But typically, we do not follow this approach for our houses. So our house, that is typically the most important investment along our life, we typically tend to act only when we see problems. So we don't bring this philosophy we use for the cars and for our health. We don't use it for our houses. And this is inconsistent, and this is not, in fact, the most adequate approach. Well, in Portugal, in particular, the conservation and the maintenance of buildings with the heritage value is not a regular activity at all. And this is more than Portugal, this is common in the southwest part of Europe. So actions on the buildings take place typically when damage is clearly visible, which implies higher costs and more time. So let's say a higher investment. So this is not good because we are sparing resources. On the other side, the scarce resources we have are typically used for relevant listed buildings, while the others, well, are not taken care. So this is not really the best way to handle this problem of conservation. In fact, we should change it. We should go in another way. And the purpose of the project was to develop a management system for heritage buildings, where you can put inside the inspection, the diagnosis, the monitoring, and the preventive conservation, using for this purpose partners from all areas of society, from universities, from managers of heritage buildings, and from companies from the private sector. And this is what the way it should be done. So this is a proactive approach. So this was really the big motivation of the project. I will just show the consortium. So this was a project, the Heritage Care project was funded by European Commission through the Interreg Web program with an amount of 1.6 million euro, involving partners from Portugal, Spain, and the south of France, so the eligible area for this program. It was coordinated by us, and it had a total duration of 3 years, so it finished more or less 2 years ago. So we were 8 partners developing the activities, and we worked together with the 11 associated partners that worked as advisors and helped us to implement the tools. This is just an overview of the partners, so you can see people coming from different sectors of society where heritage is important. In terms of objectives, so we had different types of objectives. A clear objective was, in fact, the development of this integrated methodology and associated tools for the preventive conservation of heritage buildings. This should be done using the technologies we have at our hand, like monitoring systems, virtual digital models, not only using the traditional spreadsheet. So we can do much more than that. And in the same way, we should create some standards of activities, so this can guide and help the owners to adopt good practice. Looking ahead, we also wanted to raise the public awareness about the need and the advantage of adopting activities and methods based on the preventive conservation of the buildings. And finally, because these things cannot end with the end of the project, we wanted to develop a non-profit entity that will be responsible for the use of the methodology and of the tools after the end of the project. This is also very important in this type of projects. The project itself is composed of a quite powerful and developed web platform where you can adopt one of these three approaches. So we create these three approaches in order to make the project flexible. The approach should be as flexible as possible. So service level 1 is the simplest one, the cheapest one, but the most important, in the sense that will be the most used approach. If the building is important and justifies to go to increase the level of complexity, then we can move to service level 2. And again, if complexity is really high, we can move to service level 3. So basically, service level 1 is about the inspections of the building and the development of recommendations. So a report with the results and the associated recommendation. Service level 2, besides the service level 1, includes also the inspection of the assets, the use of monitoring tools, and the use of basic virtualization of the buildings. Service level 3 takes all the information from service level 1 and 2 and develops a BIM model where all this information can be managed and integrated. We will talk about these three levels more in detail in the next slides. So the tools we developed inside each of these three service levels were tested and improved in real case studies. So we used 6 case studies for service level 1, so the simplest and most important, then 15 for service level 2, and 3 case studies for service level 3. So the development of BIM models. Just for curiosity, this is the case study we used in Portugal for service level 3. That is the Ducal Palace. So this is a medieval palace in Guimarães, where the University of Minho is located. So let's go a bit on detail. Service level 1 is about inspection. So the good way to perform an inspection. The inspection should be fast, should be reliable, should be cheaper, and it should work. I mean, this should bring advantage to the owner. We were inspired by the Monument Watch Association in Belgium and Netherlands. So here the goal was to perform an inspection on the building, try to identify the main problems, its causes, and possible recommendations to act and to mitigate the problems. This has to be done in a systematic and uniform way, and also objective approach, so the result should not depend on the inspector. In this case, we had to create an inspection checklist where we define these 11 areas of actuation. So for each of these 11 areas, we define sub areas that each inspector should follow. So this is the way to make the process as objective as possible. The same for damage. We create a specific damage atlas where we can categorize. So this damage atlas has 7 main categories, and then each category has, or class has subclasses, and each subclass has subclasses. So this was the way we adopt to make the process objective. We provide examples, so the inspector can access each of these categories and from the visit to the case study, and then identify here the problem and provide the association. This is a possible result coming from the inspection. The inspection in this project was carried out through a mobile app that has direct access to the web platform. So you can access damage atlas, so the inspection checklist, and you can go point by point and complete the inspection. This is quite simple because all this information will be integrated and can be accessible anytime. The final result is a report, a technical report, but technical reports are very difficult to be understood by the owners, which do not have technical expertise. So we create the possibility of developing an automatic report with non-technical information, and this is based on colors. So green stands for the situation where everything is okay, while red represents serious problems requiring immediate action. So in this way, the owner really understands the different situations. So even if he doesn't have any expertise and technical expertise, he can follow the non-technical report and understand the need for action. This is just one example of a possible report. Well, service level 2 is a step ahead. So it incorporates service level 1 plus a series of layers. The first layer is the possibility of performing the inspection of the assets. Can be furniture, can be paintings, tapestry. All these assets can be also included in the inspection. So for this purpose, we created a specific checklist as we did for the building. Well, this is just one example. And we created also a damage atlas specific for the assets, as we did for the building. And well, again, you have one example of a report for the assets based on this scale of colors that allows the owner to understand the message in a very clear way. Another layer is the virtualization. It's a basic virtualization because the most complex virtualization comes with the big model in service level 3. In this case, this was obtained using a drone to create this digital model based on drone, and this one based on laser scanner. So this information can be used also for navigation. Well, I provide you one example here, obtained through 360 panoramic pictures. So it is possible to create a technical virtual tour. We saw this many times during the pandemic for a touristic purpose, but in this case, so here we use the same technique, but for technical purpose. So you can navigate through the building, and you can access information either from the report. For instance, you can identify damage, the level of damage. You can access information about the monitoring system. So I just give you one example later on this point. So, and finally, the last layer is about the monitoring system. In this case, I'm just showing you the equipment we installed in our case study in Ducal Palace. So we install sensor for physical parameters of temperature, humidity, luminosity, technical structural information. We install 2 clinometers. We also have some moisture sensors, shower focus sensors, and a meteor station on the roof. As I said before, this information coming from the Musu system can be integrated with the basic virtualization models. So you can, in this case, you can navigate through the building and access the information on real time and understand, for instance, how critical is the temperature in a given room, and the same for the relative humidity. In this example, you are seeing colors to highlight the violation of thresholds. So you can see in this picture that temperature is wrong. It's not according to the indicated values, but the humidity level is okay. So I'm talking about the left picture. As for service level 3, our goal was to go for a quite complex digital model based on building information modeling. These BIM models are quite common nowadays for modern buildings, while for edge construction this is not so common. So our goal here was to develop this digital model and integrate all the previous information coming from the inspection of the building, inspection of the assets, and monitoring data. We had to create a library of elements in BIM, so elements typical of historical constructions, and also we simulate damage through patches. This is not the most realistic approach, but it's quite simple and allow us to navigate through the virtual model and identify the damage. These are just pictures of the BIM model of Ducal Palace. And the last layer, it's very interesting, not so practical nowadays yet. That is the use of smart glasses to perform the inspection. So we can, instead of using the mobile app, we can use the smart glasses and navigate through mixed reality and perform the inspection of our buildings using this glass. So we can easily access the damage atlas and we can categorize the damage we find, and this goes directly to the BIM model. Okay, we did this just on a room. This is quite complex. It still brings some technical difficulties. We believe this can be the future in some years to come, but not yet nowadays. Well, when developing these tools, we need to show them to the final user. So we performed a workshop for owners and managers to explain them the advantage of adopting a preventive conservation approach, and another series of workshops for professionals where we allow them to use the tools and understand what can be obtained from them, understand the limitations as well, and in order to disseminate this practice based on the advanced technologies. In terms of conclusions, I just want to show you the keywords of the project that are diagnosis. So based on what happened, so understand what happened to our constructions, then monitoring that allows us to understand what is happening. So the present, so we have past, present, and by integrating this information and performing management of information, we can understand what will come next. So we can understand the future. So we can perform adequate and mitigation measures to avoid the progression of damage. So in this way, we can elaborate recommendations for users so they can act on their building. So the project does not intend to act on the buildings, but just to provide recommendations either using short or more complete and comprehensive information, but the point is to provide recommendations for the users and tools for this management of the process. And to conclude, I'll leave you with our motto: so prevention is definitely much better than cure. I just give you here 3 references that you can check, and then you can find here details about the methodology developed and about the tools we use. So I thank you once again for your attention. So please feel free to contact me in case of any doubt or queries you may have about this project. Thank you.